Hi friend, how are you? Today discussing topic is about city saturation. It is very common things. We always hear this term city saturation in our substation or in the power plant. So what is the main reason why the city saturate and what is the saturation? It is the basic questions on everybody's mind. So why the city has been saturated? So what is a current transformer? A current transformer is a measuring instrument, or it is being used for the protection purpose of the substation, high or costly equipment. So current transformer saturate when the core material can no longer support a magnetic flux increase. We all know when a current flowing through the primary side of the transformer, magnetic flux has been generated. When a current is just flowing from the primary side of the transformer, this is the core of the city, and this core has been just electromagnetic field. For the electromagnetic flux has been generated. This electromagnetic flux will induce the electromagnetic induction from the primary side current, then converted to the secondary side current. If we are connecting a ammeter with the secondary side, we can measure how much current is flowing from the secondary side by electromagnetic induction. So this is the basic things of the current transformers. Why and how the current is flowing from the primary side of the transformers. And when the flux, lots of flux are just flowing or generated in the core, so the city saturation will be occur. When the core material can no longer support a magnetic flux increase, usually due to excessive primary current or the presence of DC offset. And when the flux density in the core reaches its maximum capacity, the magnetic material is said to be saturated. This saturation lead to distorted secondary current and can cause malfunction in the protective relay. So what is the main reason of the saturation? Is the excessive primary current. When the excessive primary current will flow, if any fault has been occurred, connected line or connected networks of this particular city, there may be the saturation. So high current, especially during the fault condition, can overwhelm the core material ability to handle the magnetic flux and leading to saturation. DC offset, fault current often contain the DC component which can create a permanent magnetic flux in the core. This DC component combined with AC component of the fault current can quickly drive the core into the saturation. And the open secondary circuit, if the secondary circuit of the city is open, the high voltage induced by the primary current can force the core into saturation. A high burden connected to the secondary can cause the core to saturate. And also the knee point voltage, we know all the knee point voltage is the voltage at which the 10% increase in city secondary voltage result in the 50% increase in the secondary current, making the point where the saturation begin. By help of the knee point voltage or VK, we can identify where the saturation has been just started. So by putting the 10% increase on the voltage, we are getting in the secondary voltage 50% increase in the secondary current. Or also the improper sizing is also depend for the saturation purpose. Improper sizing means if the CT is not properly sized for the expected fault current, the saturation is more likely to occur. Core material, the type and the quality of the core material also influence the saturation point. Materials with higher permeability can saturate more easily. So what is the cause of the CT saturation? The CT, if the CT will be saturated, so the distorted secondary current wavefront, making it difficult to the protective relay to accurately detect the fault. It is the main things that will happen in the CT, and misoperation of the protective relay potentially leading to unnecessary tripping or delayed tripping may be there, and also damage to the CT itself. So here for example purpose we are taking, suppose here the 20 VA CT has been considered, and here the CT load you can connect is 20 VA. If you increase the load to the CT, what is the load? Load is the connected ammeter, connected relays, and relay and the meters, different types of ammeter, different types of relays are the connected load. The connected load should be 20 VA or less than 20 VA. If the more load connected, then the saturation may be happened very easily. So here the CT primary core current flow. First of all, what happened? The CT primary current flow, when we are switching on the supply to a particular feeder and the CT has been connected to this feeder, so the CT primary current first flow. When the CT primary current has been flow, the flux has been generated. The flux induced in the core of the CT. Next, electromagnetic induction. Due to the electromagnetic induction, the current will flow to the secondary side. Current flow to the secondary side of the CT. So the secondary side of the CT. So IS equal to the secondary current and IP is the primary current. Suppose we are considering here the CT ratio of 400 by 5 ampere. So if the 400 ampere current will flow from the primary side of the CT, so the secondary current will be 5 ampere. If the less current is flowing from the primary, so the less current will be flow from the secondary side. Due to the electromagnetic induction, the primary side current are just electromagnetically induced to the secondary side, and the secondary side current is flowing as per the flowing current of the primary. So it is called the CT ratio. So the ammeter read the current, and if the connected load burden will be more, then the CT will be saturated. So it is the basic things that this is the CT burdens. So you should have to maintain the CT burden. In every nameplate of the CT you can see there the burden has been written 20 VA, 30 VA, 15 VA, 10 VA. If this burden has been just crossed, then the CT will be saturated. And we have already discussed about the knee point voltage, and by help of the knee point voltage we can easily identify that from which voltage the CT saturation will start. So I have already done this types of video about the knee point voltage, about the 5P20, 5P10 in our previous video. Please see this video for more information about what is 5P20 and what is 5P10. You can easily identify it. Please search the video and you can get the knowledge about it. So this is the today's topic, from where you can easily identify, or you can obviously know about what is saturation, why the saturation, it is the very common things, and why the saturation has been occurred in the current transformers, and for the occurrence of the saturations, what will happen inside the CT, we have already been discussed today. So if you are interested, please subscribe my channel and press the bell icon for more these types of related video, technical video in the near future. And obviously share my video with your friends and colleagues. Thank you very much.